Hello everyone. Today we're going to be taking a look at systems of inequalities. So rather than look for just those solution points that we've been talking about, what happens now when we change those linear equations, which graph into lines, into linear inequalities? How does that change what we're looking for in terms of our solution? Those are the things we want to be thinking about today. I suggest that you have some kind of pencil, regular writing device, obviously pen or pencil, as well as maybe some colored pencils or maybe some different colors in terms of things that you're going to use to shade, okay? And a calculator and a ruler is very beneficial as well. So here's what we are doing currently, or what we have been doing. We've been thinking about this idea of lines crossing and finding that intersection point. So we've been looking for one single solution, an x value, a y value, right here, where those guys intersect. So we were looking for 0.82, and that was going to be our solution. Well, how does that change then when we take those equations and turn them into inequalities? So rather than have equal signs, now we have greater than and less than symbols. So if you remember, this is when we're going to go ahead and shade. So we will graph a line and then shade a boundary region either below or above that line right there. That is the set of points that work for all of that inequality. And when we have two of them, we would shade twice. And so then our solution region wouldn't be just where the lines intersect, but rather where the shading intersects. So in this case, where mine is both shaded yellow and black, that would be my final solution region, where I have two different colors that are shaded. This is why I suggested maybe you have some colored pencils or two different colored writing devices as you go about doing this, maybe even three at some point. Okay, we're just going to look at a few examples. We're looking for that region of points where the shading intersects rather than just the lines. Okay, and here we go. Here's your first example. We have what looks like two lines here. So in order to graph, we need to, of course, get the y by himself, and then we'll make pictures of each of these, and we'll look where the shading overlaps or where the shading intersects. So for this first one, I'm going to make him be red on my graph. I'm going to go ahead and solve that one for y. I will subtract the x to the other side, and then he will become y is greater than -3 minus x. And when I go to sketch that graph, remember I'm going to start at -3, and then I'm going to go down 1 over 1 to create that slope, since the slope is in front of the x. Okay, the slope is a -1, so I'll start at -3 and go ahead and slope that line. Now before you connect the dots, be thinking, is this a dashed line or a solid line? When it's y equals, we always drew a solid line. This is just y is greater than. No equals to is even a part of that. And because of that, we're going to go ahead and dash the line to divide my coordinate plane into two regions. So when you go to sketch this in your notebooks, be thinking about drawing that coordinate plane, maybe save a few boxes on either side here. You don't have to number all the way out to 10, but get, at least 5 or 6 units away from your origin. Okay, now that I've drawn that line, you want to shade. This says y is greater than that line. We could test a point, plug in 0, 0 to see if it works. In this case, I would shade above my red line. So all of those points represent the points that work for the first inequality. I need to do the same thing for the second one here. I'm going to do that one in blue. I'm going to add 6x to get the y by himself. So then I have y is less than 1 plus 6x, or 6x plus 1, either way. And then I'll go ahead and plot that. So my first dot's at 1. And then I do a slope of up 6 over 1. And I'll go ahead, and this time again, it's a dashed line. Okay, dashed line, and I'm going to shade less than that line. Less than that line. Sometimes with these, it's a little tricky for people to see where less than would be. So again, sometimes plugging in the 0 is helpful. If you plug in a 0 at the beginning here, -6 times 0 is 0, plus 0 is still 0. Is 0 less than 1? The answer to that is yes, so we should be shading on the side where 0, 0 is. So all of this would be shaded everywhere on that side of my blue line. Now, remembering what it is we're looking for here, not just where everything's shaded, but where things are shaded twice. That is my final solution region. So I would suggest that with your pencil or whatever you're using, you darken that region because this is my final solution region. Maybe I'll even use another color while I'm thinking about it here. This is my final solution region, where both the blue and the red were when I graphed. Not just blue, not just red, but where those shadings overlapped each other. This is my final solution region. That means all of these points technically work for both inequalities that we started with. Okay, that's the goal of what we're looking at today. Let's keep going and do another one. How about this one? These already have the y by themselves, so that's kind of nice. Y is greater than -2. Y is less than or equal to negative absolute value of the quantity x plus 2. So let's first graph the top one here. We need y is greater than -2. That means place a dot at -2 on the y. And the slope would be 0. So we would be drawing a horizontal dashed line at -2. Then we would want to shade everything above that because this is y is greater than. So all of this up in here would be shaded one color or lightly in pencil. Now going to the next one. When I look at this one, I see that this one has an absolute value in it. That tells me this is going to graph into a V shape, okay? So using our shortcuts we learned, the vertex of the V will move to the left 2. There's nothing back here, so just to the left 2. That will be the vertex of my V, and I'll go ahead and slope those arms in, down 1 over 1, down 1 over 1, repeating for symmetry. And this is a solid line that I will use to connect these points, making my V shape, because it's less than or equal to. There's the absolute value V in blue, and now I need to shade everything less than that. That's underneath, inside here. And with that in mind, I should be thinking about now where did my shading overlap and find a way to darken that because this is my final solution region. It's where both types of shading occurred, my red pen and my blue pen. That is my final solution region. The points within that region work for both inequalities. Okay, let's try a third example. This will be the last one that we do. We're going to get y by itself, it looks like in that top one. So I'm going to subtract 4x. I have 2y is greater than or equal to 8 minus 4x, then I'll divide by 2. So y will be greater than or equal to 4 minus 2x once I divide by 2. That is the first one. And I will go ahead and start my plot at 4 on the y and do my slope of down 2 over 1, down 2 over 1, down 2 over 1. This is my red marking. And if I connect those, I will connect those with a solid line because it is greater than or equal to. And now for shading, we need to shade everything above that line because it's greater than. Again, sometimes it's hard for people to tell which side to shade. If that's you and you're having a tough time deciding which side to shade, go ahead and plug 0, 0 into the original. The left side would all become 0. 4 times 0 is 0 plus 2 times 0 is still 0. Is 0 greater than or equal to 8? The answer to that is no. 0 is not greater than 8, so I will not shade the 0 side. I'll shade the other side instead. So there's my shading for my first inequality. Now let's do the same thing with the second one. I'll do that one in blue. It's already solved for y, so I'll put my first dot at -3. Do my slope of down 2 over 1, down 2 over 1, down 2 over 1. Go ahead and dash this line through those points. Woo, missed the points a little bit there. And I'm going to shade everything less than that line. Less than that line. So if I continue my shading, you'll see that the shading does not overlap what I've shaded previously. And when I'm looking for the solution region where two shadings will overlap each other and it's not happening, I need to be sure to say no solution. Now keep in mind, not all parallel lines when there's shading involved will be no solution. All I would have needed to do if I would have changed this to greater than, we would have shaded the other side of the line, and then that would make some shading overlap. So be thinking about that. If that problem just had that inequality switched around, that would have changed my whole solution region. So that inequality plays an important part in determining where the shading is overlapping. Okay, that's our plan for the next few days. We'll be looking at some graphing and shading. You'll have a practice sheet tomorrow that will be shading in the overlap region, and that's what we'll be looking at. Okay, thanks for watching.